Hello everyone, fairly short lesson for you today. We'll review some right angle trig we covered previously and get you onto some practice questions. In this unit we'll be introducing some ideas that allow us to work directly with non-right angle triangles. I can only imagine all of you are probably eagerly waiting to acquire that new ability, so let's get started. So we're going to cover the sine law eventually, but today we're just going to do review. So in the past we've done sine, cosine, and tangent. For a right angle triangle, sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent, which we can remember quickly with the acronym SO, CA, TOA. So those are the equations. So first we'll do an example. It's important to label the triangle appropriately. So if this is our reference angle, opposite that we call the opposite, adjacent, and the longest side, always opposite the right angle in a right angle triangle, is called the hypotenuse. So which of the trig ratios in this triangle should we use? We have the opposite and we need the adjacent, so which of these mention opposite and adjacent? It's this one. So we're going to go tan of 67 equals opposite, which is 204.9, over adjacent, which is x, and we need to solve for x. So if we're solving for x, the first thing we need to do is bring the variable upstairs or into the numerator. So multiply both sides by x. X divided by itself on the right side is just 1. So moving on, we'll have x tan 67 equals 204.9. So we can evaluate tan of 67, which is 2.355 and some other digits. And we can just divide both sides by 2.355 and we end up with x. So we find x eventually is 86.97, which we can round to 87.0 if we're going to the nearest tenth. For the next triangle, this is our reference angle. The opposite side we do not have. We have the adjacent and we have the hypotenuse. And we need to find this angle x here. So which trig ratio mentions adjacent and hypotenuse? It's cosine. So we'll have cosine of x equals adjacent, which is 15.2, divided by hypotenuse, which is 17.8. We can evaluate 15.2 divided by 17.8. That gives us 0.8539 and some other stuff. So that's equal to cos of x. In order for us to determine what x is, we need to take the inverse cosine of this number here. So inverse cos of 0.8539 and so on will give us eventually 31.4 degrees. Now it's important with these calculations for you to be in degree mode. So probably a good check is try the tan of 45. See if that gives you 1. If it doesn't give you 1, you need to switch the mode of your calculator. So we'll do one more question, 1a on page 258. This example, we need to figure out the indicated side x. This is our reference angle. The side here is called the opposite. And the one opposite the right angle in a right angle triangle is known as the hypotenuse. So we need to figure out which trig ratio to use here. We have the hypotenuse and we need the opposite. So the trig ratio that mentions opposite and hypotenuse is sine. So we'll go sine of 28 equals opposite, which is x, divided by hypotenuse, which is 9.4. And now we just need to multiply both sides by 9.4. So 9.4 divided by itself is just 1. And x will just be 9.4 times sine of 28. Now sine of 28 should be 0.469-ish. So you can check that. So you multiply that number by 9.4 and we get 4.4 centimeters. So one thing before you go on to try these questions on your own, as you're doing them, just remember you need to use inverse, sine, cosine, and tan if you're finding angles. So sine inverse, cos inverse, and tan inverse will give you an angle. And you use just regular sine, cos, and tan if you're finding a side length. So that's it for me for today. I'll see you next time.